Let's look at another example. Suppose there are 3 cars for every 8 students at a high school. How many cars are there for 1,200 students? So I'm going to set up a ratio of cars to students. You could also do students to cars. But here I'm going to put cars on top, students on the bottom. So I know there are 3 cars for every 8 students. So my first ratio is 3 to 8. And that's got to be equal to the ratio x over 1,200, where x is the number of cars for 1,200 students. And now I just solved this equation. So that means that 3 times 1,200 must be equal to 8x. 3 times 1,200 is 3,600 equals 8x. And I'll let you do that long division. What you should get here is 450 cars. Okay, so the constant of proportionality is this value k, which I get by taking the ratio y over x. We say that y is proportional to x, and k is called the constant of proportionality between y and x. So the central idea here is that a relationship between 2 quantities is such that the ratio of one quantity to the other remains unchanged as the numerical values of both quantities change. So over here, 3/8 is my k, and the idea is that 3/8 is equal to k, and so is x over 1,200. And so we used that to be able to solve this equation. All right, let's look at some strategies for dealing with proportional problems. So I want to determine which is the better buy, 12 tickets for $15 or 20 tickets for $23. Well, in the scaling strategy, I'm going to find the cost for a common number of tickets, and the common number that we want to take is the least common multiple. So I'm going to look at 12 and 20 and find their least common multiple. That's 60. And so to get to 60, if I start with 12, I need to multiply by 5. So the price of 60 tickets is going to be 5 times 15, or $75. In the second plan, to get to 60, I need to multiply by 3. So the price of 60 tickets in the second plan is 3 times 23, or $69. Now comparing these, they both are the cost of $60, and so the cheaper or better buy is the second option, right? Okay, so that's the scaling strategy. Scale it so that you're comparing the same number of objects at once. Okay, the unit rate strategy is to look at the cost per unit. So here I'm going to want to know what's the cost per ticket in each of the plans. So in the first plan, since 12 tickets cost $15, I just divide 15 by 12. And get $1.25. So it's $1.25 for one ticket. Same idea for the second plan. Now I'm going to divide 23 by 20, and I get $1.15 per ticket. And again, I see that the second plan is the better buy. Both of these strategies are valid for approaching these problems, and you want to be comfortable with explaining either strategy to your students. One method may click with them better than another. All right, let's look at Kai, Palace, and Judy. They made $2,520 for painting a house. Kai worked 30 hours, Palace worked 50 hours, and Judy worked 60 hours. They divided the money in proportion to the number of hours worked. If they all earned the same rate of pay, how much did each earn? Well, here we have a couple of options. I'm going to let X be the unit rate, or the rate of pay per hour. Then if I want to know how much Kai gets paid, he gets paid 30 times X. What about Palace and Judy? Well, Palace worked 50 hours, so he gets paid 50x, and Judy worked 60 hours, so she gets paid 60x. Oops. So if I want to know the unit rate, I just need to say, well, their total pay, if I add up Kai, Palace, and Judy's pay, it should add up to 2,520. All right, so on the left-hand side, I can combine these terms because they all have an x. So I'm going to get 30 plus 50 is 80, plus 60 is 140. X equals 2,520. And now I'm going to divide 2,520 by 140. At this point, you've done lots of dividing, so I'm just going to pull out my calculator for the sake of time. 2,520 divided by 140 gives me $18. And so they each get paid $18 per hour. And so if I want to know their total, I need to multiply. So Kai got paid 30 times 18. Or $540. Palace got paid 50 times 18. Or $900. And Judy was paid 60 times 18. Or $1,080. All right, so here are a couple more facts. This first one is just saying that if I have two ratios that are equivalent, or two fractions that are equivalent, so A over B equals C over D, where the numerators are also non-zero, then I can flip both of those fractions and I still get equivalence. Furthermore, if I have rational numbers A over B and C over D, where A over B is not equal to C over D, then I can rewrite this as A over C is not equal to B over D. Okay, so these are just some facts about rational numbers and setting up your proportions. Proportions show up a lot in scale drawings. So the scale is your ratio of the size of the drawing to the size of the object. So here's a scale drawing of a floor plan of a house, and it's in the scale of 1 to 300. And we want to find the dimensions in meters of the living room. Okay, so 1 to 300 means that 1 centimeter in my drawing represents 300 centimeters in the house. 300 centimeters is 3 meters, right? Okay, so 3.7 meters here on the left-hand side of the living room represents 3.7 times 3, I'm sorry, I said meters, didn't I? 3.7 centimeters here represents 3.7 times 3 meters, or 11.1 meters. And down here, I'm going to multiply again by 3 to say that the width of the living room is 2.5 times 3, or 7.5 meters. Okay, so the dimension of the living room is 11.1 meters by 7.5 meters. All right, you've got lots of practice problems to try in the homework. Please let me know if you have questions about dealing with proportions.